how to, thank you, Howard, on how to master the exam PA writing. So, PA is definitely a very different exam from other exams. It's, of course, still has a math component, but the edge to passing is more on the writing and the communication than just knowing the math. So we'll jump right into it. So our learning objectives today are going to be to talk about and discuss how the SOA grades the writing. We have some great templates for the different types of verbs that the SOA uses. So to critique, compare, contrast, interpreting coefficients. And we'll learn these templates so that you can just have them in the back of your mind. So as soon as you see that type of problem, you can be like, I know how to answer this. And most of all, is just going to be boosting that confidence. Because I'm sure all of you know the material, and you just need that edge to know um, I can write this material. So again, why is writing important on exam PA? It's important because we have our modeling knowledge, but we're testing more than that. Knowing that's just not enough. We are also testing our communication skills. And so the scoring is going to depend on how clearly you explain it. So strong writing is going to be those free points that you do not want to leave behind. Today's plan is going to be, we're going to go over critiquing. We're going to go over some general writing pitfalls and how to fix them. We're going to use some Goldilocks and the Three Bears as our template to go over what's a weak answer, what's a too much answer, and what is a point scoring answer. Then we're going to go over some compare contrast, time management, when, those times when the questions ask you to make recommendations. And most importantly, because it's guaranteed to be on every exam in some type of form, we're going to go over coefficient interpretation. So questions today. You can certainly ask questions today, but what I want to do is have you give me your questions on either a specific exam question or a specific topic that you want to do a mini lecture on, and that's what we're going to do tomorrow. So if you could email me those after the webinar is over, we're going to do that tomorrow. Obviously, if I get 25 questions, we're certainly not going to get through all of them tomorrow. So we're going to do, what's humanly possible and under the time constrictions. All right, so let's hop right into it. Critiquing on exam PA. What does that mean? Right? When we think critique, we're like, oh, do you want me to just absolutely tear this to shreds and tell you why this is a horrible, horrible idea? No, it's not. Critiquing means taking a stance. Do you agree? Do you disagree? Do you partially agree? So it's not just pointing out the flaws. It's not all negative, right? Sometimes we think critique in the English language is, a negative thing. It can be positive. It can be that you agree or you disagree. So what the graders want to see, they want to see, do you understand the issue at hand? Can you explain the impact on the model or the analysis? Can you communicate the reasoning clearly? And those strong critiques are going to be clear, concise, and backed by reasoning. And so that brings us to the critique formula. Every critique should have a stance that you're taking. Do you agree or do you disagree? The reason, why did you take that stance? The impact, how it's going to hurt or help the analysis or the model. And then the optional recommendation. If asked, make a recommendation for improvement or propose an alternative approach. And that last piece is optional because some of the questions do just say to critique and justify. whereas some say to critique and recommend. If they're not asking for a recommendation, you certainly don't want to waste time typing out those few extra sentences using that extra brain power. Um, it also could be the case where it's like, task one is just asking you, or task A is just asking you to critique and justify, and then potentially task B is asking you to give that recommendation. So you just don't want to get yourself, I guess, kerfunkled. And so again, why does this matter so much? What are they testing when they ask you to critique? They're asking you to test to understand the conceptual understanding of the model decisions. They want to see your clarity in writing. They don't want to just see you doing like a jargon dump. Um, and it's your ability to justify with the evidence from what they're giving you, whether that's data, graphs, or variables. Um, and one thing that's definitely tough about PA is that a lot of these questions, they have more than one right answer, which can also make it kind of frustrating when you're trying to self-study and you're using the SOA model answers. And we'll definitely get more into that later. I'm hoping to shed some light on the SOA model answers and help you understand that they're not there's usually more than one right answer that you can get full credit on. We'll go into that. So ice cream shops. We're gonna have a scenario here. So your manager suggests removing the variable number of ice cream shops in the city. And I apologize. Mostly today, the examples we're going to be pulling from are from the last sitting, which was the fire data set. So this is an example of how you can both agree and disagree. So your manager is suggesting that you remove the number of ice cream shops in the city from a fire prediction model, right? We're thinking how can the number of ice cream shops in the city help me predict fire? So if you agree, you could say, I agree with this recommendation because the number of ice cream shops is unlikely to have a direct relationship with fire incidents, including it could add noise without proving predictive accuracy. Perfect. That makes complete sense. Like I said, what do ice cream shops have to do with predicting fires? And as you all know, including variables that aren't significant can add that noise and not help the model. But if you disagree, I disagree because ice cream shops may act as a proxy for population density and commercial activity, right? That areas with more shops might also have more foot traffic and potential fire risks. Removing it could discard useful predictive information. That also actually makes complete sense, right? Ice cream shop, super yummy. Everybody's very stressed out, and you're like, I'm gonna give myself a quick sweet treat. And yeah, population density could definitely create more fire risks. So this is like a perfect example of you really could go either way on this, and you could get full credit. It's all about being able to have that strong justification as to why you're taking that stance. Okay, and so now we're going to get into our template. So I'm going to do one for agree, one for disagree, and then eventually we're going to look at kind of a universal one. So the most important thing is that you have the first two things, right? You need your stance and your reason. I agree with this because. And then the impact. You need to tell the grader you understand that how this is impacting the model. Is it strengthening the model? Which would make sense if you're agreeing it's strengthening the model. And then again, that third bullet point is optional. That could be a recommendation, could be an extra sentence. So a tip here is to focus on why that approach adds value, avoids redundancy, or matches the problem set up. And so here's our template for disagreeing. Our stance and reason, typically I disagree with this approach because the impact, this may cause blank leading to blank. And again, the optional recommendation saying the results could be improved by this. So that's why I have it only a fast. And on this one, you want to focus on what's lost, what's misleading, or what harm the recommendation might actually cause. So here is a little pet example. So dog park project. The background is that your town council is reviewing ways to improve community health. They asked your assistant to analyze recreational options. The assistant noted that many residents own dogs and recommend building a dog park in the center of town as the best solution. And so your task here is to critique the assistant's recommendation. So here is our agree response. Number one, our stance and reason. I agree with this approach because building a dog park directly addresses the needs of many residents since dog ownership is common in the community. Definitely makes sense. That is very reasonable. And the impact is going to be it strengthens community health by encouraging outdoor activity and social interaction, which aligns with the council's goal of improving wellness. So this is like a very strong answer. It even goes that, well, not goes that extra step because you should always be doing this, bringing it back to the business problem. So that little last bit of aligns with the council's goal of improving wellness. And then again, here's a disagree response where you would also earn full credit. So I disagree with this approach because building the dog park in the center of town may create noise and congestion that negatively affects nearby residents. Barking, extra traffic, and then the impact would be this is problematic since it could reduce satisfaction for non-dog owners, and it goes against the council's broader goal of improving quality of life for all residents. And so now we'll move on to this universal template. This works for either stance, agree or disagree. So I agree or disagree with this approach because so that first sentence is just very boilerplate template. So that's I know that these goals these templates seem very simplistic, but that is the idea of them is to just give you a plug and play. If you struggle with how to open your answers and move through them. So again, this is beneficial or problematic since it will blank, which affects the model by blank. And then that optional piece, an additional improvement could be. So this fallback structure ensures that you'll always have that clear exam ready critique. Okay. So our next example, we're going to actually hop into one of the exam examples. I'm going to just take a second. Does anybody have any questions so far? Okay. So I'm hoping I'm assuming everybody is familiar. This is from the 24 sitting. So I put all the background here just to refamiliarize ourselves because I certainly don't have the questions themselves memorized. This exam was about the energy usage for land and locations in the Chicago area, I believe. So just to refresh ourselves, we have the relationship between a census block, census tract, just basically telling us census blocks are a geographical subset of tract, which is super helpful for someone like me who's never really lived in a city before. Although I suppose it is somewhat easy to tell. So they gave us this like individual tract and then the individual block group and the individual block itself. I know it can be tough under time constraints to like absorb this information super quickly. But you definitely just have to do your best. So the rest of the background was that Your manager wants to predict the residential energy usage in a block for the entire year. Some of the predictor variables are stored at more aggregate granularity than block level. Example, tract and city level detail. Given this, your manager asks you to remove all tract level and city level variables as they will not provide predictive power. So it's actually not showing, right? There's like 3 levels of granularity here. Then the city level is actually one more step up, not shown here. So we have any city level data is just going to be for the city of Chicago. Then we have our individual tract data, which will be just for that. Then the individual block, and then the individual, or I'm sorry, the individual block group, and then the individual block itself. And so the actual prompt was now to critique your manager's recommendation to remove that city level data. And I literally just plugged and played into our template. So completely, I agree with the manager's recommendation because city level variables do not vary across blocks. And that's what we're trying to predict, right? Your manager wants to predict residential energy usage in a block. So that makes sense, right? This data set was, I believe, just for the city of Chicago. So any of these city level variables, it's only one city. So it's going to be the same for each block. Say it was like the total precipitation for the city of Chicago as a whole, right? That's not going to vary by block. And so the impact on this would be that it strengthens the model since the variable would be constant for all rows. It's not providing anything, right? It's just kind of putting that noise into the model itself and distracting the model fitting from looking at the data that is actually going to help that predictive power. And so the optional would be following this recommendation also avoids unnecessary model complexity by reducing the number of predictors. In this case, I would say you certainly don't need that. It's just an extra piece. That would not hurt. But I think you could get full credit with just the 2 first sentences and not waste that precious time with the 3rd sentence. Okay, so now we're going to look at this compared to the SOA's response. So the SOA's response does fit into this. They say they agree with the manager's recommendation. Adding the city level detail does not improve the model since it's all from the same city. Data is all from the same city. Excuse me. And for the impact, they used, for example, in a linear model, a city level variable would have a single level and therefore no coefficient estimates. This is because the values would be constant for all data points as this data set only spans one city. And then the optional, and again, this was in my opinion, we should remove. So they stated right at the end of the problem that, we should remove the city level detail for prediction of block level energy usage in the entire year. It's not a horrible sentence. It's just at the end kind of summing up your stance. But they just ask you to critique the recommendation. I don't think that last sentence is needed for full credit. You're just kind of restating what you are telling the analysts to do. And so that's what's tough about using the SOA's responses as your go-to model, right? That's all you have when you're studying Um, but again, as I mentioned earlier, in a lot of these cases, there is more than one right answer. And so you may like kind of harshly grade yourself when you're like, okay, well, I didn't say that in my answer, so would I have gotten full credit on that? The best thing to do is just focus on answering the question. So if you had a stance, a reason, and an impact, you would have gotten full credit. So on to example number 2. And this is task 2B from October 24 within the same realm of this uh, asking about the tract level data. And so okay, so the first one was remove. Okay, my apologies. So the original background was to remove all tract level and city level. So now we're talking about should we remove the individual tract data? And so this one was disagreeing. I disagree with this approach because tract level variables, they can still give useful information. They show how blocks are different in other tracts. Removing it may cause the model to lose predictive power since the tracts can capture important differences across neighborhoods. Then again, this optional piece and improvement would be to retain tract level variables, but recognize that they don't add information within the tract itself. And then the SOA's response, they also disagree and are saying along the same lines that the tract level detail is less granular. It is less granular, but it can still provide predictive power for differentiating the block energy consumption for residences in the different tracts. And then they went on to say, while this will not improve predictive power of block level energy consumption within a single tract, it will improve the overall models since there's many levels to the tract variable within our data set. And they didn't go further to say, they didn't say we should not remove tract level, they didn't go further on that last sentence to say we should not remove tract level. So like, that's a perfect example of like they're not using cookie cutter things. And so if you hadn't had this last sentence, you would have gotten full credit, right? Because their response here doesn't have that last sentence and their response is full credit. Now we're going to look at task 3A from April 25. And the background is, so this was the data set on the fire. So your assistant decides to cluster the cost of incidences using the variables easting rounded, northing rounded, and notional cost. And they created these clusters and they provided a graph and summary statistics. So the easting and northing rounded, they're like coordinates, like geographical longitude and latitude in the United States. So here's the graph and the summary statistics. We can see here the magnitudes of easting and northing, excuse me, and then we can see that it created the 8 clusters. So what you're, kind of what you're supposed to be getting from this cluster analysis is that there are clear clusters, right? The differences in each sector are enough that the clustering mechanism was able to capture them. And this is representing the different types of the different neighborhoods. The differences could be coming from maybe certain neighborhoods are more densely populated. Maybe other neighborhoods have a lot of older buildings, which potentially consume more energy. Other blocks, maybe it's a mix of old buildings and new buildings, so that's maybe not driving the difference, but maybe it is more densely populated because the buildings are all high rises and they have 20 floors each, whereas the buildings in another cluster, maybe they're only 10 stories each. Um, so that's what you should see when you look at the cluster analysis. And then the summary statistics. The biggest thing was seeing the absolute massive difference um, in the magnitude of notional cost versus the northing rounded and easting rounded. Um, so we had our minimum for notional costs, our minimum is 352 and our maximum is 433,000. That is a huge spread. But within that, the percentiles are in the hundreds. Whereas for northing and easting, um, the maximums are somewhat in line. The maximums for northing and easting are somewhat in line for the maximum of notional cost, but all of the different percentiles, they're in the hundreds of thousands, which is a massively different scale than being in the hundreds for notional cost. So here is our prompt, which was to critique the clustering approach. And this time they did ask to recommend improvements. So the model answer is I disagree with this approach because the variables are on very different scales. Notional cost is much larger than easting and northing values, so it will dominate the clusters, right? That is one of the classic problems with cluster analysis. If you're going, you need to look at the variables you're putting into your cluster analysis to make sure that they are on the same scale. So what does that impact if we use these raw inputs and notional cost and easting and northing are on these different scales? The impact is going to be the clusters are going to be based on mostly cost, leading to poor groups for location. The outliers in the cost also make the clusters less useful. So we can tell there's definitely outliers in notional cost, right? That maximum is 433,000, whereas our median is 388. That's quite the difference. And so the recommendation which was needed here, the results could be improved by normalizing the variables and removing cost outliers before clustering. Generally speaking, normalizing is recommended for clustering. I think that's a big piece that's taught for in whatever study manual or course that you're using. It's an important piece to clustering. So this was supposed to be a group activity, but I don't know how to actually break y'all out into groups. So we'll just go over it together. So this was 3B. So your boss still wants to use the clusters in part A, along with other variables to predict notional cost. And so we wanted to critique this approach and justify your reasoning. So this was just the reminder I was going to leave up that you can use the universal template. And the tip on this was to focus on data leakage and whether the clusters are valid predictors. So, what I'll have you guys do? Spend like 3 minutes, throw together a response and drop it in the chat. So I'll give you guys till 10:33 and I'll look for the responses in the chat. All right, so that is 10:33. Um, I don't, oh, there we go. I don't think I see anything in the chat. Um, all right, so I'll give you guys another minute. All right. So we'll go with so Jordan said, I disagree with this approach because using the clusters along with other variables will lead to target leakage. This is problematic since target leakage can result in the model giving unreliable predictors. An improvement would be to take out any of the variables that were used to create the clusters. So that's Jordan, that's great. It's definitely along the right lines. Um, we could improve that by making sure to um, kind of throw in there um, we have data leakage because the cluster is including our predictor. Um, so let's go to the debrief and discussion. So great opening sentence. I disagree with this approach because the clusters include notional costs, which is also the target variable, right? That is classic target leakage. And the SOA, um, they do tend to test target leakage on a lot of sittings. So the impact, this is problematic since it introduces target leakage. Literally writing that sentence will get you some points. This means that the model is cheating by indirectly including the outcome variable in the predictors. So, and then the improvement would be to rebuild the clusters just using easting and northing and not using notional cost so that they provide that independent predictive information. So with data leakage, the biggest things that you want to mention are um, that you recognize that you're giving the model you're either directly giving the model information about the target variable in a predictor, and the other form of target leakage is that you are giving the model information that is only known that is not known at the time of prediction. So this can come in like a couple different varieties of flavor. Okay, so yeah, definitely, I'd say definitely practice your target variable responses because that is like a pretty common question that they ask. And here is the SOA solution. So their stance and reason, this is not a feasible solution since we are using the target variable inside the explanatory variables, the clusters, um, causing data leakage, right? That's the impact. And then, did this one ask for? No, this one didn't ask for a recommendation, but they included it. You would need to remove the notional cost variable from the clustering and redevelop clusters without that variable. So as you can see, most of the time, the SOA solutions do fit into this kind of three-step stance plus reason, impact, and then that optional suggestion. Again, I want to harp on answering what is asked. So if they're not asking that recommendation, try not to waste time on writing those extra couple of sentences. That's paying attention to what they're actually asking is such a critical skill to have. I've graded papers for students, and that's definitely one of the biggest things I see is just adding some additional information at the end that is great. It's true what they're writing. They're not false sentences, but it wasn't needed for full credit. So that's the end of section one with the critiquing. Um, I know that the models or the templates seem very simplistic, but that is the idea. These are just plug and play. You use them, you do them over and over again so that when you see critique this, you literally attack that keyboard and start saying, I disagree with this because blah, 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 blah. This is problematic because blah, 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 blah. And then you're like, okay, I just did that. That is so great. And I didn't really have to put much extra energy into structuring my response. Um, and that saves your precious brain power on this exam as well. Okay. Does anybody have any questions? Okay. So we're now going to move on to common pitfalls that lose points, right? We don't want to lose points. We want to gain points. So one of the most, I would say, and I'm sure that you've seen it as well, with the SOA feedback on the problems in the model solutions is copying output. They'll be like, oh, the student just copied the output from question A. Either from question A or what I'm leaning more towards here is, I apologize. I'm mixing up copying answers from prior questions. This is copying output. So this answer, yes, you will absolutely, yeah, you guys can have access. I'll have Howard send these slides after the presentation. And yeah, because that'll be great for you guys so you can see the templates. Because the two handouts that we were talking that you saw advertised are a little bit different. You'll get those as well, but they don't actually contain the exact templates that I have in the slides. So I'll have Howard send you the slides. No problem. So copying output, right? You get some output, they give you, the SOA gives you a table. The background is probably something like your analyst ran this model, and this is the AIC, and then they made this change, and now this is model B, and this is the AIC for it, right? That is like grade A classic SOA structured problem. So, and then they ask you to, they give you this output and then they say, make a recommendation on which model is preferred, and probably potentially with some other background based on the business problem, saying, does the client want an interpretable model, or are they focusing on predictive power? So this weak answer, let's say it was like a 2-point problem. You may get like 0.5 points for this, to just say the AIC model for a model A is 325 and the AIC for model B is 317. And so model B is lower, right? You're not telling them anything new. You're not showing that you can interpret the output of the AIC. A stronger response would be to actually interpret those numbers and tell them that model B is preferred because its lower AIC indicates a better balance of fit and complexity. You could actually combine both of these and state the actual AIC numbers. That's not a terrible idea. But the point being is, like, just having that first weak answer, maybe 0.5 points out of 2. Just adding that second sentence would get you the other 1.5 points. And so our fix with this is to always interpret what the numbers mean. Don't just restate them, right? Anyone can do that. As a strong actuary, you need to be able to interpret things as you come into positions when you have client-facing jobs, right? I work in retirement planning. Um, where I'm an enrolled actuary, so I'm a signing actuary and I'm a consultant. And um, if I just tell a client this is what your benefit is, um, that means nothing to them. I have to explain to them um, what the plan is doing, how the costs are being generated, and things like that. So pitfall number two is forgetting the business link, right? The SOA they love to see that you're linking it back to the business problem. It's really tough especially under the time constraints of the exam. We get like, you get going in the exam and you're so in the details. We forget what we're doing it for, right? We're doing all of this analysis for a potential client, right? To help them solve a problem that they hired us and they're paying us to do. Um, so that is something, always try to take it back to the business link. We love to see that. So this would be a question where the SOA gives you some outputs on they're giving you the diagnostic plots. So you have a diagnostic plot and you can see, say, that typical kind of funnel on the residual plot. So the residual plot shows heteroscedasticity. Awesome. I'm so glad. Yes, it does, but that's not helping me. The SOA is going to be like, yeah, that's awesome. I'm so glad you saw that, but I can't give you full points for that. Again, I would say this weak part, if it was a 2 point problem, you'd maybe get half a point for that. And don't hold me to that. I'm not an exam grader for the SOA, but just using kind of intuition and common sense, I would say you'd get partial credit on that. But the stronger answer would be to say the residual plots show the heteroscedasticity, right? There's your 0.5, suggesting that the prediction errors vary with cost level, and this may reduce accuracy in forecasting high cost fires. Right, that's the classic issue of having a right skewed predictor. And that's, just those last two pieces, there's your other 1.5 points. So with this, always connect the statistical findings back to the business content. All right, pitfall number three is hedging filler. Sometimes you just want to brain dump a little bit and be like, I know this about this, so I'm going to write it. And so that's the filler part. And then the hedging is like, you're kind of like teeter-tottering, and you're not taking a stance. So weak is the model might maybe help in some situations, but could also not work well, right? That's not telling me anything useful. And it sounds wishy-washy, right? Kind of always try to think about it in the context of would that help a client if I was just like, well, this like might help in this, but it could also not work well, right? It's not helping them. So a stronger response would be the decision tree model improves interpretability for managers, but it sacrifices some accuracy compared to logistic regression, right? I mean, granted, that strong response, you wouldn't be saying that to a client because they would have absolutely no idea what you're talking about. But presenting it to maybe your manager to then bring to a client the ultimate decision. So you want to avoid those hedging words, maybe, kind of, and the filler. You want to stick to stating the pros and cons clearly. Pitfall number 4, wasting time, right? This time with this exam is what, 3.5 hours. They go by very quickly, as really any SOA exam does once you get into the weeds of it. Don't spend 20 minutes trying to perfect one interpretation. Do, when you can, use the templates. State the direction. This wasting time is aimed at coefficient interpretation, which we will go in depth into in some later slides. So do use a quick template when you can. State the direction of the effect of a coefficient, the strength, is it small, moderate, or large, and the eventual business impact. So use those templates for efficiency and move on once the answer is complete. So the takeaways for this were, don't just copy, you need to interpret. Don't just analyze. When you can, link it back to the business problem. Don't hedge, be decisive, and don't overdo it, be efficient. Okay, so on to our Goldilocks and the 3 bears. Is this answer too cold, too weak, or is it too hot? It's kind of overkill, or is it just right? It's very strong. So this is task 10A from the April 2025 exam. You're interested in creating a tree-based model to predict fire. You begin by creating a bar chart to illustrate the proportion of each incident group. And so here is on the next page. The prompt is to explain what makes data imbalanced and recommend, one method to address the imbalance in order to improve predictive power. I personally am not crazy about this prompt. The way it just says explain what makes data imbalanced. I think it should have said something like explain what's making this data imbalanced. We can obviously see false alarms dominating, which actually, if you think about it in the realm of whether it's 911 calls that are coming into fires, or again, a lot of times you get to think when a 911 call comes in, 911 operators, they get kind of like, they get flustered people trying to explain what the potential emergency is. The 911 callers are doing their best to interpret that. And a lot of times they hear something that could be part fire, and they want to dispatch those fire engines as quickly as possible, right, in case it is a fire. But a lot of times it is a false alarm. So it's not shocking that we're seeing that being the biggest frequency. Special service incident groups, that could be probably like maybe ambulances are needed and things like that. And then again, the true fire is quite low, which is a great thing. It is hard to stop for a minute and like kind of think through rationally why we're seeing the data we're seeing, right? It is super hard to interpret these things in the context of the real world. Like, this makes rational sense why we're seeing this. We get really bogged down into just trying to interpret the numbers in the sense of what the SOA wants to see to the questions they're asking. But do try to think back to rational real world, right? These are real data sets. But I could see that being very tough on, like, especially the data, or not the data, the energy usage exam, like with all of those, the data dictionary with the kilowatts and this and that. Like when I read that first, I'm like, I don't know how energy works. I don't even know how energy gets to my house. Like, so it can certainly be hard to like try to connect that to a real world, because like, I'm sure very few of us have experience working with energy usage. But you know, do your best. This data set was not too bad. we're all can use common sense to figure out what drivers of fire and response times and how many engines they're sending out. I was lucky enough to have the data set when I took the exam. I had the Houston adoption, pet adoption data, and it was, it was the data based on like pet adoptions before COVID and then during COVID and after COVID. So, I mean, I'm sure there's a lot of pandemic pets out there. So like before I even really got into it, I was like, oh, okay, I know what they're getting at here, that there's definitely going to be a different distribution of pet adoptions before COVID, during COVID, and after COVID. That was an awesome data set. And I'm praying that you guys get like a very interesting and engaging data set for your sitting. All right, so moving on. Again, so that was the prompt. Explain what makes the data imbalanced and recommend one method to address the imbalance in order to improve that predictive power. So here is a weak response. The data is imbalanced because one class happens much more often than the others, so the model could just predict the majority class. It's a clear sentence, it's true, but it doesn't mention a solution method. So let's say, how many points was this problem? So this is a 2-point problem. Maybe you'd get 1 point here because you did indeed explain what makes the data imbalanced. But that like second half, so the model could just predict the majority class. It's kind of weak. You could definitely go into a little more detail there about how the model, what having this imbalanced class is doing to the model. So here is our too hot. It's filled with filler and fluff. So I'm going to read it out, and like you can literally see it's just a very long answer. So imbalanced data is a situation where the outcomes are not spread out evenly. Perfect. That is true. And this can cause problems because the model will see one type of result more often than the other type of result. Perfect. That first sentence is really perfect. I would say if we were to improve the weak answer, this first sentence would be just like the perfect improvement upon the weak answer, and that would get you most of your credit. This is something that can really make it hard for the model to give fair results. That's true. I would say that's good to include in your answer because it ends up focusing too much on the group that shows up the most. When this happens, the model might not perform as well as we want. One way that people sometimes deal with this problem is by trying to change the data in some way so it looks more balanced. There are different ways to do this, but the overall idea is to make the data easier to work with so the model doesn't just learn the obvious majority pattern. So like I would say the first half of this response was really good. It was on par. The second half is kind of where it goes off course. So it's wordy, it's repetitive, it's meandering. It says something, but it never actually directly names the oversampling or undersampling and gives that recommendation. And that, like in this problem, was really what the SOA wanted to see. They wanted to, in order to get full credit, you had to give the definition of imbalance and then have it at the end lead to either mention oversampling or undersampling. And so here's our just right. The data is imbalanced because most observations fall into one outcome. So a model is trained directly on, a model trained directly on it may always predict the majority class. To address this, we could oversample the less frequent cases or undersample the more frequent cases to create a more balanced data set. And that's it. That's full credit. And that's what, 2 sentences. And I'm gonna go like a little more into at some point, actually, or maybe I'll do it now. No, I'm gonna do it later about what the number of points means in regards to your answer to a question. But so this one was a good one. It defines the imbalance, it explains the risk, and it gives a clear syllabus approach fix. And this is exam scoring language. Now, if you had given a little bit of a longer answer that had kind of like something along the lines of these first two sentences in this one, that would have been fine too. I wouldn't say like, oh, my, like, don't focus on making your answer short for the sake of making it short. It is really just all about answering the question, right? There was 2 points you had to hit here. It was explain what makes the data imbalanced and to recommend one method. All right, so we are on to the next section. Before we start that, it is 11 o'clock, so we're halfway through today. Let's take a 5-minute break and we'll come back at 11:05. Thank you, Howard. So we're going to go over now compare and contrast. Another biggie that the SOA loves to ask, along with the critique and recommend. And so we're going to give you another simple structure that you can, when you see these problems, you can think, oh, I know how to answer this, and help you get right into actually answering the problem rather than thinking, how should I structure this? And just having a structure, it makes it much easier for the grader to follow. And that is how you get those points. So step one is going to be identify, excuse me, what's being compared. It's usually stated in the question. This is more of a mental task. As we go through these examples, you'll see that I skip step one on all of these, because again, it's more of a mental task, but we'll go over one example where, like, I'll show you how it is very important to actually determine what is being compared, because some of them can be a little bit confusing. It's easy to miss the topics. So step two, you're going to state your similarities. You're going to state your differences. Step three and step four is going to be to provide the recommendation if asked, as always, or just like a little, summary conclusion that kind of puts things succinctly. All right, so here are our templates. So step two, again, I skipped step one here. I know that these templates seem simple, but that is the idea. It is plug and play. So we're going to state our similarities. We're going to say both blank and blank are used for blank. They're similar because blank. And that's it. You got two nice sentences there. Stating the differences, unlike blank, blank does this. And, say Model A provides this while Model B provides this. And the key distinction is that this. And so then you can kind of put this conclusion overall, while both approaches are similar in this, the key difference is this. Therefore, I recommend this because of this. Again, that step four can be optional. So we are back to the dog park. The background is that the city is now analyzing data from two local dog parks, Paw Meadows and Barkside Commons. Each park collected data on dog activity levels, which is measured by the number of tail wags per minute, and owner satisfaction ratings on a scale of 1 to 10. The analyst suggests two possible ways to measure dog park happiness. And it's Model A is going to use the average number of tail wags per dog as the key metric, but Model B is going to use the average owner satisfaction rating as the key metric. The city council wants to know which metric they should use to report dog park happiness in their upcoming community newsletter. And now the city council wants to know, oh, sorry, I guess I repeated that last bit. And so the task is going to be now to compare and contrast methods A and B as measures of dog park happiness. Recommend which one should be used in the report. So this question is asking for that last step of recommendation. And so here's our solution with the templates. So step one, obviously, they're just asking us to compare and contrast methods A and B. Very simple. So here we go. Both A, tail wags, and B, satisfaction ratings. And it's important. It's not a bad idea to put in parentheses, or like refer back to the problem, what method A versus B was, just to be super clear to the graders and to yourself to keep you in line. Both method A and B are used to measure dog park happiness. Perfect. That is literally a similarity. They are similar because they summarize information collected at the parks and give an overall picture of enjoyment. Very simple, but it drives the point home. Unlike method A, which measures dogs' behavior directly, method B is measuring the owner's opinions. Tail wags provide an objective signal of how excited the dogs are, while ratings provide a subjective view of human satisfaction. The key difference is that one reflects dog activity while the other reflects human perception. Pretty straightforward. But again, it gives you this nice little template that you don't have to think about your opening and closing statements. So overall, so we were asked for a recommendation here. Overall, while both approaches are similar in capturing dog park happiness, the key difference is that ratings are easier, that the human ratings are easier for the community to understand. Therefore, I recommend method B because it gives a clearer message to the public. And that's it. I mean, it is as simple as that. I realize this is a simple example. And a lot of the a lot of the work in exam PA is actually the analysis in your mind to understand what these models are doing. And so I get it. This is a simplified example. So we'll go over an actual exam question now. So example one for our compare and contrast is task 6C from October 2024. And this actually doesn't directly have to do with that data. It is compare and contrast the receiver operator curve with the area under the curve in the context of model performance evaluation. So our similarities are both ROC and AUC are used to check how good a classification model is. They're similar because they both use the true positives and false positives to measure performance. Right? The ROC is directly related to, like, that's how you get your points for the plot, and then the AUC is measured from that, so they are inevitably both using those metrics. Not metrics, but those calculations. The ROC, so here's our differences. The ROC is a curve that shows model results at all cutoff points, while the AUC is one number that summarizes the curve. The key difference is that ROC shows the full picture and AUC gives a simple score. Perfect. That is really the key difference. And then the conclusion, so the recommendation is not needed. So this is just more of a conclusion. Overall, both measure model performance, but AUC is better for quick model comparison, and ROC is better when we want more detail. So it's kind of like ROC, really the main difference is that ROC helps you decide, helps you see like your model at hand and how it's behaving and what different cutoff points look like for you to decide for that model. But the AUC is used to compare different models. And so that's definitely the key difference. And so here is the SOA solution fit into the template. Both ROC and AUC are used to evaluate the performance of binary classification models. So they just used a little bit more specific language, whereas we just said they're used to check how good a classification model is, or you could say how well a classification model performs. And then the differences. The ROC curve is a graphical representation of a classifier's performance across all of those thresholds. They also mention the true positive rate and the false positive rate. And then they hit that point that the AUC is a single value representing overall performance of the classifier. And it is the area under the ROC curve. So I guess they gave just like kind of a little definition. So you can see how it hits all of these points. So this template is legitimate to help you answer these compare and contrast questions. Okay, so here is where step one becomes quite important, because some questions ask you to compare across two dimensions, like predictor type and model type. So the example here is, and this is just generic, compare and contrast model 1 versus model 2 using metric A and metric B. That means you really should be commenting on 4 things. So it's going to be model A on metric A, model 2 on metric A, model 1 on metric B, and model 2 on metric B. You know, if you come across problems like this, you may want to like literally write those 4 things out for yourself to try to hit all 4 points. I know it feels like a lot, but it's kind of just like you're just applying the templates more than once. So here is an example of that. Your assistant uses k-means clustering to create clusters using the 2 variables northing and easting. Your boss proposes to use these clusters in GLM, and I'm sorry. Your boss proposes to use these clusters in GLM and tree-based models for the prediction of the target variable notional cost instead of using their untransformed values. And so your prompt was to compare and contrast using clustered variables versus using the variables without modification. So this is where like you really had to like kind of think on step 1. They are asking you to compare 4 things here because of the background. So your boss proposes to use them in a GLM and tree-based models. So that's kind of dimension 1 is the model type. And then dimension 2 is the predictor type. And it wasn't, you know, I could see that it's not completely clear here with just the prompt. So that does lend itself to the fact it is important to pay attention to that background information. So dimension 1 is going to be our, like I said, our predictors is our clustered versus raw coordinates. And dimension 2 is the models, GLM versus tree-based. Sorry, I just kind of repeated that here. So we're going to have the 4 possible comments are going to be our clusters in the GLM, our raw coordinates in the GLM, our clusters in tree models, and our raw coordinates in the tree models. And again, if you were on the exam, you might just like kind of throw that, like make 4 spaces for yourself under the answer and just put those down and try to address all 4. Of course, if you can't get all 4, you get stuck, you know, then that's what happens. You don't comment on all 4. But just be aware that they are looking for, there's 4 possible things here. So, okay, so step 1, I just went over that. The similarities. And that's what I said, like, if you can comment on all 4 with the templates, great. This problem was less about the similarities, so you do have to use some subjective judgment on the template of step 1 with or step 2 with the similarities and the differences in step 3. So this sentence here really was not needed. It's this would kind of be filler, but I put it here for just to like cover it. So yeah, it's obviously both approaches bring in the same underlying information, the geographical location of each block. Pretty basic there. So more of the meat of the problem is the differences. And so, like I said, they can seem overwhelming, but we're just going to apply the templates more than once. So our first application is going to be for the GLMs. And we're going to talk about both the clusters and the raw coordinates. So the clusters, they simplify the geography into groups, making it easier for a GLM to capture the non-linear regional patterns. And the raw coordinates, they provide exact values, but GLMs may struggle if the effective location is curved or irregular. I believe I don't know if it was before this question or after, or it was probably, if this is task 3C, it was task A or B, where they asked you, where they said the assistant wants to use the clusters, in a GLM. Oh, they asked you what the implicit assumptions would be if you used a GLM, and the implicit assumptions were that the response variable has a linear relationship with both of these predictors, the northing and the easting. So, right, if there really is no linear relationship, just using a GLM with those raw coordinates, it's really not gonna it's not gonna help you much. The model's not going to be able to extract the information that those predictors have to offer. Whereas the clusters, they extract some of the information beforehand and make it easier for the GLM to extract that for purposes of predictive power. Because it makes sense. I mean, the GLM northing and easting, it's certainly not just like an exponential or linear relationship. It's much more complicated than that, with these geographical points. And so that's the first application for the GLMs of the differences. And here is the second application for the tree-based models. So the points of this was that the trees already handle nonlinear and interaction effects with raw variables. So there's no need to cluster. There's no need to do clusters before putting them into a tree-based model. And adding the clusters can actually reduce the flexibility and may discard usable detail, can actually hurt the tree-based model. And so our conclusion is just that, and these were the points that they wanted you to hit for this answer. The biggest thing being that, like, you don't need clusters for trees. It's better to use raw variables, and that the clusters help more in GLM when there are these non-linear regional patterns, which there are. And so that's what the conclusion here is. Clusters are more often effective for the GLMs since they better capture the geographical patterns, but the raw coordinates are generally more effective for the tree-based models since they're already built to handle those things. So again, back to the beginning, it seems like a lot, but if you just break it down into the pieces and then apply the templates, it becomes a lot easier to manage, and you'll make sure you hit all those and kind of not get lost along the way. So that brings me to the end of this section. Just to recap our key tips. Always follow this same structure. Identify in your mind what's being compared, or actually write it down when you have that multiple dimensions. You're going to state the similarities, the differences, and give your conclusion or recommendation if asked. And then just the points about apply the template twice if it's involving those 2 dimensions. Be balanced. Examiners do want to see both common ground and key distinctions. My tip is to not overcomplicate. They're looking for a clear, well-structured answer, not an essay. All right, on to some quick time management strategies. So this is what I'm going to kind of talk about the points. So 70 points, 3.5 hour exam is about 3 minutes per point. And as you know, the tasks vary by number of points. Here is where I would think that students get frustrated when trying to use the SOA model solutions as they grade themselves and try to work through the exams as you're self-studying. It can be like the SOA, it's like a 2 point problem, and the SOA puts like 2 sentences and that's it. And then it can be a 1 point problem, and the SOA writes like an entire paragraph. And so, as far as like when you see 2 point versus 3 point, you may think in your mind, you're like, well, this is a 3 point problem. Like, I don't know what else to write, but it's 3 points. So I feel like I need to write something more. I feel like my answer is not long enough. Try to discard that mentality. I think that it's more, I mean, overall, no matter what, it is about answering what is asked. I think sometimes the point value may have more to do, and I don't have this confirmed. Again, I don't work for the SOA, and I'm not a grader for the SOA. I think sometimes the point value has more to do with the difficulty of the topic and maybe like the obscurity of like how you have to really extract the information from the background that they're giving you in order to correctly answer the question. So if you're someone who gets stuck on like, oh my God, I wrote 2 sentences and this is a 3 point problem, this can't be right, try to discard that. Just focus on answering the question. Um, and again, this 6 minutes versus 9 minutes, it's just a guide. If you have a 3 point problem and you've been working on it for 20 minutes, it's probably time to move on. Um, when I was studying, I would find that, I would use that as a guide. But what happens sometimes too is like, everybody has topics that they're like super, super comfortable with that they absolutely have mastered. And when they come across one of those questions, they're like, okay, I know this at the snap of a finger. So you could have a 2 point problem that you have quote, quote, 6 minutes allocated to, but you answer it in 2 minutes. And so that gives you extra time on other problems that you need a little bit more time to analyze, digest, and come up with that answer. So don't freak out. These are, again, just guides. So here's a strategy for quick wins. This is my strategy, and it's a strategy to consider. Take it with a grain of salt. What I would do, I want to say when I took the exam though, when I took it, it was definitely it was 5 hours. It was a much longer exam, but I think they gave us 15 minutes in the beginning of the exam to just read it. And I know they don't do that anymore. Um, I know it can seem like wasted time, but my suggestion is to skim through the entire exam before you actually start writing and do things like identify the low-hanging fruit, right? Low-hanging fruit is going to be questions where you're identifying outliers, where they're asking you to state something about skewness. And I name pros and cons. I'm sorry, not so much that one, but I would say another low-hanging one is coefficient interpretation. Um, do the questions you immediately know the answer to and don't have to think about. Like, just get those out of the way. Save, like, those are just like instant points, right? And then you can also identify the questions that contain the topics that you know you struggle with, so you can save them for last, right? Use your brain power that you have and all that momentum you have in the beginning, and right, it's a marathon, not a sprint. On the questions you know you can answer. And the nice thing with the way that they're structuring the exam now, it to me it looks like the questions, the tasks are more disjointed. Um, when I took it, it really was like in like order, and it still is to a certain extent, like, EDA first, and then doing a couple models, and then recommending the models, and then like kind of like a summary at the end. It looks to be a little more disjointed now, so I think that you're okay if you skip around a little bit. But um, above all, my like strong suggestion is to skim through it and do the questions that you're like, I know the answer to that question. Get it done, and then you don't have to even think about going back to it. Um, Pretty obvious. Don't spend too much time. Don't chase perfection. One clear sentence can earn those points. Um, and pretty obvious. If you guys are taking exam P, you've definitely taken SOA exams prior. If you don't know the answer, come back to it. What happens, I think this definitely happened for me where like I'm like, I don't know the answer to this. Then while I was working through the exam, something hinted at the question earlier. And then I'm like, oh my God, that's what they were asking. And then you're able to like, you're able to now answer that question from earlier in the exam. And I strongly, strongly, strongly suggest quickly proofread what you wrote before you move on. You're under the gun. Typos happen, but the small typo, like you're like, I knew the answer to this question, but I made a small typo and it literally made it read the opposite of what I wanted it to say. Like I said, I have graded papers for students, and that was definitely something I saw where it's like, I know I could see you knew the answer to this question, but you wrote the opposite and you didn't go back and read it. So again, these taking this little bit of extra time to do these couple of things can save you points for sure. And this is writing for the graders using a professional tone. Do write like you're addressing a client. I mean, again, you're not writing an essay. It doesn't have to be perfect, but the SOA graders do expect to see a professional tone. Your answers should read more like consulting memos, not homework. It's okay to like it's okay to use bullet points and things like that. Um, but don't have it be like so disjointed. You want it to be clear and polished and business focused. Um, you don't when I say not like homework, like you don't want it to be like look like your grocery list. And so here is like this is the next slide is kind of like this continued. Um, Common tone mistakes is like slang. Um, I mean, it's not exactly slang, but saying like this model is like kind of better. It's not a good look. Definitely try to use that professional tone. Overconfidence. This is the only correct model. It is very rare that there is only one correct model, as I hinted at earlier in the seminar. A lot of these questions can have more than one correct answer. And then the other one is jargon dump. Don't try to avoid this. The QQ plot residuals indicate a non-normal tail distribution without robust correction, blah, 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 blah. It, it, if it's not helping the answer, don't jargon dump. It can just make it look like to the graders that you were just trying to fill and make it sound like you know what you were talking about, but maybe you didn't actually answer the question. So professional alternatives to this model is kind of better would be model A is preferred because it balances interpretability and accuracy. The alternative to this is the only correct model would be based on the metrics provided, model B appears more suitable for the sponsor's needs. And then the jargon dump would be better way to say it would be the residual plot suggests the model may not capture variation at high costs, which could affect prediction reliability, right? You said what they wanted to hear without putting all this jargon about non-normal tail distribution, robust correction. Um, so yeah. And now we'll go over a couple word choice precision. So you want to say, you want to use predicts over causes. So a weak answer would be roosters crowing cause the sun to rise, right? You know that doesn't cause the sun to rise, right? The earth spinning causes the sun to rise. A stronger way to say it would be the rooster crowing predicts that the sun is about to rise. Um, so you can see those two things are saying, those two sentences are saying very different things. So that I hope hits home on the use of on the choice of your words. And so here's a more exam focused response. Having more calls causes higher notional cost versus having more calls predicts higher notional cost since they are strongly related. The key here is careful words equal professional credibility. So the next precision is use association as opposed to proofs. So wearing flip-flops proves it is summer. Wearing flip-flops has an association with summer weather, but it doesn't prove it, right? I mean, I think we all wear, like a lot of people wear Adidas slides in the winter with socks. Wearing flip-flops or sandals certainly doesn't prove it's summer. And again, I hope this hits home as to, you can see like those sentences next to each other seem silly, right? And so the same thing applies for the exam. High income proves that customers will buy insurance, as opposed to high income shows an association with purchasing insurance, but it doesn't prove it. And that makes complete logical sense. So the last one is use improves accuracy, not is perfect. There is very rarely perfect models. So the weak one would be using GPS is perfect for directions. Using GPS improves accuracy and finding your way, but it can still make mistakes. And then you start yelling at your GPS. Adding, so back to an exam focused, adding cluster variables is perfect for predicting fire cost. No, it certainly is not. A better way to say that would be adding cluster variables improves accuracy in predicting fire costs, but no model is perfect. No model is perfect, but having an imperfect model, right, is better than having no model at all. So kind of our takeaways here, structure for polished writing. Start with your recommendation or your claim, support with the evidence, whether they're metrics, visuals, coefficients, and link back to that business impact. Okay, so now we're on to Goldilocks and the Three Bears number 2. This is task 4A from April 2025, which was about collinearity. The background was the fire department is interested in understanding the past drivers of high costs. You begin to perform data exploration on the numeric variables to assess whether they should be included in the model, and you produce the following scatter plots. So here were our 2 scatter plots for pump count versus notional cost and pump minutes rounded versus notional cost. This is a 1-point problem. Identify a potential issue with including both pump minutes rounded and pump count in a GLM. So here's our weak answer. Both pump minutes rounded and pump count should not be included in the model because they're related to each other. Again, it's a complete sentence, but it's weak. It identifies the relatedness, but it does not name collinearity or explain why it's a problem. And those were the 2 key points you had to hit in this to get that 1 point. So here is our too hot. I'm going to read this very quickly and show you just how irrelevant it is. When looking at these 2 variables, it's clear that they are kind of similar because they both deal with pumps. Pump minutes rounded is about the time and pump count is about the number, and obviously time and number are connected in real life. If there are more pumps, you'd expect more minutes, and if there are fewer pumps, you'd expect fewer minutes. So if you try to put both into a model, the model might get confused because it doesn't know which one is really causing the change. It's also possible the graphs look kind of the same, which makes it hard to decide. Overall, it just seems like a lot of overlap, and that could be a problem. This just kind of danced around it. It never actually used the term collinearity or connected why matters in modeling. Like it was getting very close, but it didn't actually really hit any of the key things like stating collinearity that you needed to get that 1 point. And so our just right is the scatter plots indicate that pump minutes rounded and pump count may be strongly correlated. This collinearity makes it difficult to estimate their individual effects, leading to inflated standard errors and less interpretable coefficient. So this is a high scoring. Well, this would get you full credit because it's using the correct term of collinearity. It's explaining the consequence, and it's tying it back to interpretability. And I just want to point out that we use the term that the scatter plots indicate that they may be strongly correlated. That could sound like you're not taking a stance. In this case, those words are appropriate here because we only have the scatter plots, right? This is like kind of like that. This is like a first step to checking if we have collinearity. So we can't tell that there certainly is. We can't tell 100% that they're correlated from those scatter plots. So here, it is okay to use that word maybe. And so here I'm laughing because this is a clear indication of like, this is a 1 point problem, and this was the SOA solution. You can see it's very long. So that number of points, it doesn't always dictate how long your answer should be. And I can understand how that can certainly be frustrating when you're trying to use these model solutions to help yourself study. So I'm just going to read it very quickly. Based on the one-way charts provided, there's a clear linear relationship between these two variables, as well as between notional cost. So they're pointing out that there's linear relationships between each predictor and the target. Given the linear relationship between these two predictors and the target, it's possible that pump count and minutes rounded also have a linear relationship, i.e. collinearity. And so you can see that they even use that language. It is possible. And that's appropriate here because we're pointing things out based on a limited amount of data. And I think it can go both ways. It wouldn't be appropriate to say here, it proves, these graphs prove that there's a linear relationship between pump count and minutes rounded. And that again just kind of lends itself to like why this exam is difficult. It's kind of like it's a careful dance of knowing when to use this correct language. And it's very intricate. So just finishing this up, the reason collinearity is an issue is that it makes the effect of the individual's variables difficult to estimate, leading to the higher standards of coefficient estimates. So they hit on all 2 or 3 of those points. They maybe could have said it in a more succinct manner. But yeah, again, the number of points, it doesn't always dictate how long your answer should be. All right, so now we're on to, and I think this is probably the last topic we're going to get through today. We have a few more to go over tomorrow, along with your questions that you send me tonight, or if you could send them to me right after this so that I can put together material for tomorrow. Big thing, recommendation questions, pick 1 point and stick to it. When they ask you to recommend an approach, they want you to choose one option and clearly justify it. Don't hedge by writing about both options. It looks very uncertain and will cost you points. Again, even if multiple answers could receive full credit, you'll only earn full marks if you commit to one and explain why it works. This lends itself back to like our ice cream shop example, where um, we were recommending whether or not to, or we were critiquing whether or not to remove the ice cream shop variable to predict fire. Again, those you could agree or disagree, and both were full credit. But if you agreed and disagreed in the same problem, it's confusing and you would lose points. So confidence and clarity are rewarded. Covering every possibility is not. So rule of thumb here is to make one clear recommendation, back it with 2 or 3 strong reasons or sentences tied to the data or diagnostics, and stop there. So this is an example. This is task 5B from April 2025. Recommend either a log transformation or the use of a log link function in modeling the response variable. And the response variable, I think, is notional cost, right? And I don't think we talked about this in depth, but it was a right skewed variable. As you could see, we did touch on it in the clusters question, because you could see that the minimum was like in the hundreds, but the maximum was in the hundreds of thousands. So that's clear evidence of a right skewed variable. So the SOA's feedback was that either recommendation was awarded full credit with strong justification. They literally verbatim wrote what I have been harping on. They wrote, most candidates chose the log transformation and explained it well. Fewer candidates provided sufficient detail to justify the log link. So that my key takeaway here is pick one, but pick the one you feel most comfortable with. Justify it clearly and don't hedge. Even if you aren't fully comfortable with either, just stick to one. Don't try to go into either of them looking to get full credit. You're thinking, oh, well, I'm not really sure about either, so if I write both, maybe I'll get credit. Don't, just stick with one. So our poor student answer to the recommend either the log transformation or the log link was, I think you could use either a log transformation or a log link function. A log transformation would help stabilize the variance and make the residuals more normal. On the other hand, a log link would model the relationship between the variance and the mean. Both have pros and cons, so either could be reasonable here, right? Because they wanted you to justify your choice. This loses points because they never committed to one, reads more like a list of facts, and it doesn't answer the question. Perfect example of hedging. You're not going to get full credit. So our strong answer, I'm going to do both. So the strong answer on recommending a GLM with a log link. A log link function is recommended for modeling first pump attendance time. Using a log link allows the variance to scale naturally with the mean, which matches the pattern seen in the diagnostic plots, where residuals spread out at the higher fitted value. This approach also produces interpretable results on the original scale. Perfect. We picked one, we gave the backup, and we would get full credit. And then here's the other side, just to prove you could do either. A log transformation of this is recommended. This transformation reduces the right skew observed in the distribution and lessens the influence of extreme high values that distort the model. It also stabilizes variance across the fitted value, helping the residuals better meet normality and constant variance assumptions. So again, these are both good answers because you just picked one and you stuck with it, right? This one does not mention anything about doing a log transformation, and this one doesn't mention anything about using a log link. I'm not even going to read this because I just said all of this. So our key rule here, clarity over coverage. Don't waste time writing about both options. pick one and back it up with detail. Okay, so we've got about 11 minutes left. Um, I'm going to open it up for questions now. So you can see the next section is our writing strategies about interpreting coefficients. We're going to go real heavy into this tomorrow. A lot of, we're going to go over the templates for each of the cases. So like I said, we're gonna definitely really go into detail on that and talk talk in depth about that. So I'll open it up to questions. I'm curious, could could you guys open up and tell me, or just drop it in the chat? What do you think? What are the topics that you struggle with the most? Are there any like specific topics? GLM and unsupervised. Okay. GLMs, I know everybody struggles with the GLMs. I think when we go through, as we go through these, yeah, link functions. So we're gonna go in these, we're gonna go into them hot and heavy tomorrow. And I will add some more background and focus maybe more a little bit on more of a lecture style on GLMs tomorrow to help y'all feel more confident on these. We'll point out the big differences because I think that is what makes it difficult. It's like you get down, you're like, oh, I understand linear models, and then it's hard to bridge that gap going from a like plain vanilla linear model to the GLMs with the link functions. So we'll definitely do that tomorrow. If anybody wants, you could also drop me one or two specific exam questions that maybe you want me to cover in detail. You don't have to drop those right now. You can email me after, um, and I will just drop my email address in the chat. So feel free to email me. And I guess so. I don't want to get into the coefficient interpretation in these last 10 minutes because it's a pretty long section. So what we could do is instead we'll do the third Goldilocks and the Three Bears. Okay, so this is the third Goldilocks and the Three Bears, showing us three different levels of responses. We have task 7A from April 2025, which was about the GLM assumptions. So this was the question I was kind of referencing earlier. Background, your client has been concerned about the false alarm rate in past years. To better allocate resources and reduce unnecessary responses, you're asked to build a model to predict the false alarm rate from historical data. Your boss suggests location, the northing and easting, longitude, latitude, might help explain the false alarm rate. Your assistant decides to use a GLM instead of a tree-based model for this exercise. So here is the prompt and the plot, the scatter plot we were given. Explain what assumptions about the relationship between easting and northing and the false alarm rate are implicit in your assistant's choice to use a GLM instead of a tree-based model. So when I first looked at this question, I was like, I don't understand what I'm supposed to be getting from this scatter plot. And then later it dawned on me that think about the type of scatter plots we see when we're comparing when we're looking for relationships when we're doing like our first, we're doing like multivariate EDA. When we're looking for relationships among the predictors themselves. The point here was that there is clearly no linear relationship between these. So it's clear that using a GLM, which we'll see in the answer, assumes a linear relationship between the predictors. It's not going to do anything for us. It's not going to help us. The model's not going to be able to capture any meaningful relationship from these. So our weak answer is a GLM assumes that easting and northing are related to the false alarm rate in a simple way. So both variables might not be modeled accurately. Like, I mean, yeah, of course, any model is going to assume that they're related. Um, but I guess, saying it in that simple way, it's not hitting on the fact that we needed to say that it's assuming a linear relationship. So again, at least it's a full sentence, but it doesn't clearly say linear relationship or and it doesn't connect it to the neighborhoods, right? That was the other big points of this. Like this is supposed to be a map, right? Because these are like longitude and latitude coordinates. And we wanted to see like, can we get any information from there being differences across neighborhoods? Which we know that there are from that from the cluster analysis. You could clearly see it. So the too hot would be um, by specifying a GLM with standardized easting and northing covariance. The analyst implicitly constrains the functional form to blah 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 blah. This is way too much. It's far beyond the it's not far beyond yet. It's far beyond the PA syllabus, right? This is just like super high level. We don't need to go into this type of high level. Assuming a monotonicity across the coordinate planes and disallows detection of subregional discontinuities and clustering or threshold effects. That is way too much. Chill. The just right is going to be the GLM assumes that false alarm rates change linearly with easting and northing. This means it can't capture neighborhood specific effects where the rate may change non-linearly across locations. So it names the assumption, the biggie, the linearity, and explains its limitation in plain business terms. And that is our exam scoring language. So that's all that I have today. I know we have about 4 minutes left because I don't want to get into these other two big topics that we have left.
Ali, could you go back to the template for compare and contrast by any chance?
Yeah, let me find it on my other screen though. Let's see if I'm able to. Here, I'm going to end this one and do this. There we go. So this one,
Yes, perfect.
do you have a question on it?
No, I've been writing it into my Word doc.
Oh, okay, okay. I can I'll send everybody. I'll have Howard send everybody the slides. I'll just send you the whole slideshow. I mean, obviously there's some stuff on here we didn't go through today, but I don't mind especially if you want to look at it tonight. Um, you may actually get more out of it tomorrow. Um,
Okay. I was
The,
just
the
going to use like
recording the
the.
recording will show everything too. So I mean, you could pause the recording while you're watching it if you want.
Okay, gotcha. I was just going to take a practice test after, and so I just wanted to use the templates as I went.
yeah, absolutely. The other part, you know what I could do? I'll take these and I'll put them into the handouts, which we'll send um probably within the next hour. So you guys I definitely want you to have all of these, as I'm sure a few of you are going to take practice exams today. So we'll send those along.
Okay, perfect. Thank you.
Yep. Best of luck on your practice exams. And we'll all meet tomorrow. is anyone thinking that they're gonna send me like any specific questions like from the exams that they're struggling with and need more want like an in-depth explanation of, or is it just gonna be I'll add some content on basically a mini lecture of the GLMs?
I think I'll probably send a couple questions.
Okay. All right, yeah, just email them to me. And I hope today was helpful. I know it's a lot of repetitive, but like that is the idea. Um, Kind of lower level things to just like take just like save your brain power for the analyzing, right? You don't want to have to sit there and think, oh God, how do I start this question? So that's all I have for today. And I look forward to seeing, well, hearing, no, not even hearing. I'll see y'all tomorrow.